We have our sprinter. Sprinter is going to exert a forward force of 160 newtons. Okay, it's going to encounter some air resistance, and we know that they're starting from rest. So actually, I didn't ask you to do this, but why don't we do this? One of the first steps really that you should do on most of these problems is to draw a free body diagram. Call it FBD for short. We did some of them yesterday. So for example, we know in this problem that there's a thrust force. We'll call it F thrust. And actually we know the number, right? What's the thrust force? 160 newtons, pushing them forward. We know there's a backwards force of air resistance trying to slow them down. Call that F air. And that is 50. Now, in terms of the context of the problem, this is really all that's important. But technically, there's actually two other forces acting on our sprinter. What else is acting on the sprinter? Gravity's pulling them down. We can call this Fg, but actually I just gave you a new name for F gravity. What is it? Weight. So you could label this either as F gravity or weight. That's what weight is. How much gravity is pulling down on you. That's what we call weight. There's one more force. The ground. Yeah, the ground is pushing back up. F ground. The ground is pushing back up on us. And actually I gave you another name yesterday. What did I say that name was? The normal force. And actually, why don't we just define the normal force now? This is a force due to a surface pushing back on an object. It's really kind of a reaction force, like in Newton's third law. Like there has to be another force before the surface can push back on something. And in this case, it would be gravity's pushing down and the ground's going to push back up. And the word normal is, it's always perpendicular to the surface. The normal force will always be perpendicular to the surface. Okay, so that's just a sidebar. We're going to get more into the normal force tomorrow, but just, you know, for a little preview. Okay, let's find the weight. So this should be the easiest question on the test. Whenever I ask you for the weight, everyone should be able to get this one right. It should see 100% correct answers. How do we find the weight? Well, it's not quite that easy. I didn't actually give you the weight, but it's still an easy calculation. How do we find the weight? Okay, mass times gravity. Right, so to find the weight, you're just going to multiply the mass times the accelerator, whatever planet you happen to be on. And most of the time we're going to be on Earth in these problems that you do. Sometimes they'll say, you know, what's your weight on the moon? Typically are not going to be using negative 9.8 here. We're going to deal with that negative in a different way. So go ahead and just leave it positive. So what's 60 times 9.8? Oh yeah, pull out your calculators if they're not out yet. Oh, that's fun. You could probably do this one in your head, right? $50. Okay, so that'd be our newtons, 588. By the way, your weights are typically going to be large numbers, okay? They're not going to be like, okay, I weigh 150 pounds. They're not going to be anything like that. These are a whole nother unit. Okay, letter B. What was B? Find the net force. Find the net force. Okay? Well, hopefully this should be somewhat straightforward. Okay? So, just like the tug-of-war problem, we have the sprinter going forward with 160, and there's some air resistance pulling him back. Well, what's his net force? 110. Right, so you're just going to kind of subtract that. So 160 newtons minus 50 newtons gives us a net force of how much? 110 newtons. So that's our net force. Yeah. We should. What direction should this be? To the right is good. Or east is good also. All right, letter C. Acceleration. Okay, how are we going to find the acceleration? So we're going to use Newton's second law, and this is the big equation of the unit, which basically says Fnet equals, what's it equal? Mass times acceleration. Fnet equals mass times acceleration. So notice we were given we just found our net force, 110. Notice that we don't use the thrust force. We use the net force. And you have to be careful in the problems. Sometimes they'll give you like the individual forces, the forward force and the air resistance. And sometimes they'll just give you the net force right away. So just make sure you identify. Look for that word net force. If they give it to you all right away, you can find the acceleration right away also. So 110 equals, what was our mass? 60 times A. $83. Letter D. How fast will she be moving after 5 seconds? How are we going to figure this out? Use our kinematics. Good. So we're not going to get away from our kinematics equations. We're still going to utilize them. Notice, what's our V initial? Okay. What's our time? And what is our acceleration? What's the crossover variable between last unit and this unit? What's the common variable? The acceleration, right. So the big variable, the big equation for this unit is Fnet equals ma. A is the crossover. So sometimes they'll give you acceleration, sometimes you have to find it. You'll use kinematics from time to time. Okay, which one's going to be good for us? The nice easy one. Zero plus 183 times 5. Nine point what?
1.5.